So welcome back to the eighth part of Identities, Trigonometric Ratios of Multiple Angle. I have already uploaded 7 parts. I'm pretty sure you are watching. Let's get started. Hello intellectuals, I am SK Thakur and you are watching this video in Digital Maths Academy.
In the house, SK Sir on the lead. Let's ride.
You see 37 number. It means I have already solved 36 identities in the previous parts. You are watching, I am pretty sure. So in 37 number, sine cube 10 degree plus cos cube 20 degree equals to 3 by 4 times cos 20 degree plus sine 10 degree. So we are going to choose left hand side, correct? So left hand side equals to sine cube 10 degree plus cos cube 20 degree, isn't it? So we need 4 sine cube 10 degree, isn't it? So I am writing here 1 by 4 times 4 sine cube 10 degree plus 4 cos cube 20 degree. Next step 1 by 4. See carefully here. We have 4 cos cube 10 degree, isn't it? So remember one formula. I'm just going to write here formula, right? And the formula is here sine 3a. Sine 3a equals to 3 sine a minus 4 sine cube a, and cos 3a equals to 4 cos cube a minus 3 cos a. So from sine 3a we can derive the relation of 4 sine cube a. Here 4 sine cube a equals to 3 sine a minus sine 3a. Yes, definitely you can derive, 4 sine cube a equals to 3 sine a minus sine 3a. And from here, 4 cos cube a. 4 cos cube a equals to, this minus 3 cos a goes to the left side, no? So this becomes cos 3a and plus 3 cos a. Isn't it? So 4 sine cube a. So I am just going to apply this formula here. Right? Look carefully. This formula, isn't it? 4 sine cube a. So when you apply, then we will have here 4 sine cube a. See, 3 sine a minus sine 3a. So at the place of a, we have 10 degree. So 3 sine a, a means 10 degree, minus sine 3a, 3 into 10 degree. That's clear? Okay. After that, plus, we have 4 cos cube a, and at the place of a, we have 20 degree. So we are going to apply this formula here. Isn't it? So let's apply this formula. So we can write here cos 3a, cos 3a, a means 20 degree, plus 3 cos a, 3 cos 20 degree. Isn't it? Let's simplify it, okay? So we can write here 1 by 4 times. Now, just once again, you are going to look here 3 sine 10, isn't it? And 3 cos 20. So can you take 3 common? Definitely you can take 3 common, right? So we are going to take 3 common here. So when we take 3 common, between 3 sine 10 degree and 3 cos 20 degree, we will have sine 10 degree plus cos 20 degree. Okay, next, minus sine 3 into 10. So we can write here sine 30 degree. Okay, plus cos 3 into 20, 60 degree. Isn't it? Okay. Next step, we have here 1 by 4 times 3 sine 10 degree plus cos 20 degree and sine 30 degree. Sine 30 degree gives 1 by 2 and plus cos 60 degree and cos 60 degree is also 1 by 2. So we write here 1 by 2. Now 1 by 2 plus and 1 by 2 minus will cancel, and remaining we have here 1 by 4 3 1 by 4, 3 sine 10 plus cos 20, isn't it? And 3 1 the 3, so we can write at last 3 by 4 times sine 10 degree plus cos 20 degree, and it's our right hand side, so we can write equals to right hand side and root. Identity number 38. 4 times cos cube 20 degree plus sine cube 50 degree equals to 3 times cos 20 degree plus sine 50 degree. So we have to choose left hand side. So we can choose left hand side here. Left hand side we have 4 times cos cube 20 degree plus sine cube 50 degree. Let's open the bracket. That is 4 cos cube 20 degree plus 4 sine cube 50 degree. Now remember the formula of 4 cos cube A and 4 cos cube A. Okay, 4 cos cube A and 4 sine cube A. Okay, just look at here. 4 sine cube A equals to 3 sine A minus sine 3A. Remember, and 4 cos cube is equal to cos 3A plus 3 cos A, isn't it? So 3 sine A minus sine 3A, and here is a cos 3A plus 3 cos A, isn't it? So we have to apply the formula here. Okay, so we have here 4 cos cube A, isn't it? Not to forget the formula. Okay, 4 cos cube. Once again, see here 4 cos cube A, cos 3A plus 3 cos A, isn't it? Cos 3A plus 3 cos A. Here, cos 3A, cos 3 into 20 degree plus 3 cos A. 3 cos A, isn't it? So here is 20 degrees at the place of A, so not to get confused. And similarly, here is a 4 sine cube A. What's the formula of 4 sine cube A? 4 sine cube, once again you can see here, 4 sine cube equals to 3 sine A minus sine 3A. 3 sine A minus sine 3A. So 3 sine A means 50 degree minus sine 3A, 3 into 50 degree. Right, so better to write the formula, inside the bracket. We can write here, okay, 4 cos cube A equals to cos 3A plus 3 cos A, and 4 sine cube A equals to 3 sine A minus sine 3A. So to make it more clear, if you write formula inside the bracket, it will be better. Next step we have here cos 3 into 20 degree. So you can write here cos 60 degree, and between these two parts, okay, 3 we are going to take common, so that's 3 is common. So we have cos 20 degree plus sine 50 degree and minus sine 150 degree, isn't it? Okay, cos 60 degree. What's the formula of cos 60 degree? Cos 60 degree equals to 1 by 2, isn't it? And plus 3 cos 20 degree plus sine 50 degree minus, so what's the value of sine 150 degree? 150 degree equals to sine 180 degree minus 30 degree, isn't it? And sine 180 degree minus 30 degree means sine 30 degree, because sine is positive in second quadrant. So we can write here directly sine 30 degree means we can write here 1 by 2. Right? See carefully here. Sine 150 degree equals to sine 180 degree minus 30 degree, isn't it? That gives us sine 30 degree, and sine 30 degree means 1 by 2, isn't it? Okay, now we can cut 1 by 2 plus and 1 by 2 minus, and the remaining we have here 3 bracket cos 20 degree plus sine 50 degree equals to right hand side and root. Identity number 39. Tan A plus tan pi divided by 3 plus A minus tan pi divided by 3 minus A equals to tan 3A. We have to choose left hand side. So left hand side is tan A plus tan pi radian over 3 plus a minus tan pi radian over 3 minus a, isn't it? Pi radian means 180 degree, and 180 degree by 3 means 60 degree, isn't it? So we can write here tan a plus tan 60 degree plus a minus tan 60 degree minus a, isn't it? Pi radian by 3 equals to 180 degree by 3, that is 60 degree. Okay, next step. You have to remember the formula of tan a plus b and tan a minus b. So here tan a plus tan a plus b, tan a plus tan b over 1 minus tan a dot tan b. Here 60 degree is at the place of a and a is at the place of b. Likewise here also same, tan 60 degree minus tan a over 1 plus tan 60 degree dot tan a. Yes, formula tan a plus b equals to tan a plus tan b divided by 1 minus tan a dot tan b, isn't it? And if you have here minus, there will be minus and there will be plus. It's correct. I am pretty sure you are understanding. Next step is that we know the value of tan 60 degree, and tan 60 degree gives root 3. So we can write tan a plus, that's root 3 plus tan a over 1 minus root 3 tan a, and here minus root 3 minus tan a divided by 1 plus root 3 tan a, isn't it? So 1 minus root 3 tan a and 1 plus root 3 tan a, we are going to take LCM, isn't it? So let's take LCM. So when you take LCM, we'll have here 1 minus root 3 tan a 1 plus root 3 tan a. Be careful here. Tan a, the denominator is 1, so we can write tan a bracket 1 minus root 3 tan a 1 plus root 3 tan a, isn't it, for this part, and plus here the numerator is root 3 plus tan a, right? And according to the work of fraction, we write inside the bracket here 1 plus root 3 tan a, isn't it, for this part. The next one is here minus, this part we can write root 3 tan a minus tan a, isn't it? Root 3 minus tan we can write, and after that another, it is 1 plus root 3 tan a, so we write here 1 minus root 3 tan a. Okay, minus sign will be here at the numerator. That's clear? Okay, next step, just we are going to simplify it. Here it is tan a 1 minus root 3 tan a and 1 plus root 3 tan a plus b and a minus b equals to a square minus b square. So we write here a square 1 square minus root 3 tan a its whole square, isn't it, for this part. Here we are going to multiply this, isn't it? So when you open this bracket by root 3, we write here root 3 into 1 root 3 plus root 3 into root 3, that is 3 tan a plus tan a here, and after that plus tan a into root 3 tan a means root 3 tan square a. It's clear? Okay. Here is minus, so we write here minus, and the product should be inside the bracket. So root 3 into 1, root 3, root 3 into root 3, we write here 3, so we write here 3 tan A. After that, minus tan A into 1, minus tan A, and minus minus plus, we write here tan A into root 3, so we can write here root 3 tan square A. Isn't it? Look carefully. Isn't it? Okay. And at the denominator, we write a minus b and a plus b, means a square minus root 3 tan A and its whole square. It's clear? Now, I'm just going to simplify. So here I can write tan A, and 1 square is 1 minus root 3 tan A whole square means 3 tan square A, correct, plus we have here root 3, this root 3, 3 tan A plus tan A, 4 tan A, isn't it? This 4 tan A plus root 3 tan square A. Okay, simplifying and changing the sign, okay, because minus sign is outside, so we write here root 3, so it becomes here minus root 3, correct. Minus 3 tan A minus tan A means minus 4 tan A, and when you open the bracket by negative, that becomes plus 4 tan A, right, and this becomes minus root 3 tan square A. Okay, and now at the denominator we have here 1 minus 3 tan square A, correct. Okay, after that, see carefully here. Okay, root 3 tan square A plus and root 3 tan square A minus, we can cut, isn't it? Root 3 plus and root 3 minus, that also will be cancelled. Remaining part we have here, open the bracket, tan A into 1, tan A, minus, we write 3 tan cube A, is correct. Here plus 4 tan A plus 4 tan A, we can write 8 tan A. Okay, and at the denominator we have 1 minus 3 tan square A. Okay, next step, just look here, tan A plus 8 tan A means 9 tan A, and here is a minus 3 tan cube A. At the denominator we have 1 minus 3 tan square A. Sure. Okay, next one. So we are going to take only 3 common, okay, not more than 3. Okay, we can take tan A also common, you know, but only 3 is taken common here. Why? It comes in formula. So when you take 3 common, we'll have here 3 tan A minus tan cube A over 1 minus 3 tan square A, right, and 3 tan A minus tan cube A over 1 minus 3 tan square A, it's in the form of formula, right, tan 3A, not to forget. Okay, so lastly you can write here 3 tan 3A, isn't it? Just like write here formula here, that is 3 tan A minus tan cube A over 1 minus 3 tan square A equals to tan 3A. Okay, and what's at the right hand side? 3 tan 3A, yes, here is or not? 3 tan 3A, isn't it? So that's our right hand side. We write here that's equals to right hand side and proved. Identity number 40. Cot A plus 45 degree minus tan A minus 45 degree equals to 2 cos 2A over 1 plus sin 2A. So we are going to choose left hand side. So left hand side we have here. Left hand side we have cot A plus 45 degree minus tan A minus 45 degree. It's correct. Apply the formula of cot A plus B and tan A minus B. So here cot A plus B equals to cot A dot cot B minus 1 over cot A plus cot B. Clear? Tan A minus B, that's tan A minus tan B over 1 plus tan A dot tan B. It's better to write the formula inside the bracket, okay? So I'm just going to write the formula here, that is cot A plus B equals to cot A dot cot B minus 1 over cot A plus cot B, and tan A minus B equals to tan A minus tan B over 1 plus tan A dot tan B. Yes? Okay. After that, we know that cot 45 degree means 1, cot tan 45 degree is also 1, isn't it? And after that, we have to bring cos 2 and sin 2, you know, that's the sin and cos at the right hand side. So better to change cot into sin and cos, okay, that will be better. So let's we change. So cot means cos A by sin A. Into 1, no need to write, okay, or you can write also 1 times any number, 1 anything is the same, right? So minus 1, here also same, cos A by sin A plus 1, isn't it? Cot 45 degree equals to 1, minus, here is also tan A, that is sin A by cos A minus 1, and here 1 plus tan A is sin A by cos A, and into 1 no need to write, and if you write doesn't matter. After that, let's take LCM, okay? So it's the main line, and here sin A is your LCM, okay? That is sin A, that's sin A LCM, and we can write cos A minus sin A. It is also same, cos A plus sin A over sin A, right? Minus same process here also, you know, there is a cos A, and we can write sin A minus cos A, and here that is cos A plus sin A. Okay, now sin and sin A we can cancel, okay? So remaining parts we have here, look, remaining part we have here cos A minus sin A over cos A plus sin A minus sin A minus cos A over cos A plus sin A. Clear? So we can take LCM. LCM is cos A plus sin A, and LCM and the denominator same, you know, so we can write the numerator as it is, so it becomes cos A minus sin A, and here is a minus, and it becomes minus sin A, and here minus plus cos A, not to forget, okay, don't forget it, otherwise it will be wrong. And the next step we have, let me do over this side, isn't it? So here cos A plus cos A, that becomes 2 cos A minus sin A means minus 2 sin A. Here cos A plus sin A. Next step we can take 2 common, cos A minus sin A, and here cos A plus sin A. Now if we see the right hand side here, you know, cos 2 is at the numerator, isn't it? So cos 2 means cos square minus sin square A, right? So we need cos A plus sin A, cos A minus sin A at the numerator. So just we are going to do here, just we can do here like this, okay, into cos A plus sin A over cos A plus sin A, right? Isn't it? So next step is that it's 2a minus b, a plus b, isn't it? So that gives us cos square a minus sin square a, isn't it? Next step, cos a plus sin a, cos a plus sin a means cos a plus sin a whole square. So we can write cos square a plus 2 cos a dot sin a plus sin square a, isn't it? Okay. After that, 2 cos square a minus sin square a equals to cos 2a. So that's a 2 cos 2a. And here cos square a plus sin square a 1, and 2 cos a dot sin a or 2 sin a dot cos a same. So we can write here sin 2a, isn't it? And it's our right hand side, cos 2 cos 2a over 1 plus sin 2a. You can see the right hand side, and we have got the same here, isn't it? So lastly we can write here equals to right hand side and proved. Identity number 41, tan a plus 45 degree minus tan a minus 45 degree equals to sec 2a. So we are going to choose left hand side. Here left hand side we have tan a plus 45 degree minus tan a minus 45 degree, right? So we are going to apply the formula tan a plus b and tan a minus b, isn't it? So here tan a plus b is tan a plus tan b, that's 45 degree, and here 1 minus tan a dot tan 45 degree, it is minus tan a minus tan 45 degree over 1 plus tan a dot tan 45 degree. So a is at the place of a, and it is 45 degrees at the place of b. So better to write the formula inside the bracket. So we write here tan a plus b equals to tan a plus tan b over 1 minus tan a dot tan b, isn't it? But if there is a minus, here it becomes minus, here it becomes plus. Okay, you know that. Okay, now next step is here tan a. We have to bring sec 2a, and sec 2a equals to 1 by cos 2a. So cos 2 is at the denominator, at the right hand side. So let's change tan into sin and cos. So tan a gives us sin a over cos a plus 1, and here 1 minus sin a over cos a into 1. Okay, here is a into tan 45 degree, that's 1 minus, same here also sin a over cos a minus 1, at the denominator we have here 1 plus sin a over cos a into 1. It's correct. Now take LCM here, simplification, so here is a cos a, so we write here sin a plus 1 into cos a, that's cos a. At the denominator we write cos a, here also same, cos a minus sin a. At the denominator we have here cos a, here is minus, same process, sin a minus cos a over cos a, and here is also cos a plus sin a and over cos a. It's correct. So now we can cut cos and cos. Here also you can cut cos and cos, isn't it? And look here at another side. Okay, sin a plus cos a, just right here sin a plus cos a over cos a minus sin a. It is negative sign minus sin a minus cos a over cos a plus sin a, isn't it? So next step we have to take LCM. LCM equals to cos a minus sin a. There is also cos a plus sin a. And work of fraction all of you know. So cos A minus sin A, cos A minus sin A, according to the work of fraction, we write here sin A plus cos A and cos A plus sin A. Same, x plus y and y plus x. So we write here sin A plus cos A and its whole square, isn't it? And here also same, cos A plus sin A, cos A plus sin A, they are same. So sin A minus cos A, and there is a cos A minus sin A. It's correct. Remember now. It's a logical something, So we need cos A minus, here is cos A minus sin A, right? So we write here sin A minus cos A, and here is cos A minus sin A. Look here. Okay, just see carefully here, nicely. Okay, now here we apply formula, after one line. So let me write here sin A plus cos A, its whole square, minus, see here, sin A minus cos A and cos A minus sin A minus B into B minus A, So when we take common from here, so it becomes sin A minus cos A, right? And this sign becomes plus, isn't it? And so we will have here sin A minus cos A, its whole square. You understood or not? A minus B and B minus A, So if you take minus common from B minus A, it becomes A minus B, right? So here, this becomes sin A minus cos A, and sin A minus cos A into sin A minus cos A means sin A minus cos A whole square. And here, A minus B into A plus B. That gives us cos square A minus sin square A. Isn't it? Right? So here, A plus B whole square. What can we write here? A square A plus A square, right? A square dot 2 sin A dot cos A plus cos square A. A plus B whole square means A square plus 2B plus B square, isn't it? Yes, you can write. And next step we have here. See, here is a plus A minus B whole square, that is sin square A minus 2 sin A dot cos A and plus cos square A, isn't it? And at the denominator we have cos square A minus sin square A means cos 2A. Okay, now 2 sin A dot cos A plus and 2 sin A dot cos A minus, we can cut them, isn't it? Let's cut it by red color, right? So we can cut it. Sin square A plus cos square A, that gives us 1, isn't it? Again we have cos square A plus, okay, listen, sin square A plus cos square A 1, isn't it? And after that sin square A plus cos square A equals to 1. So we can write here 1 plus 1 over cos 2A, that is 2 over cos 2A, that is 2 sec 2A, isn't it? And look at the right hand side here. Okay, we have 2 sec 2A, isn't it? So we write here at the last equals right hand side, and proved. Identity number 46. 2 sin theta over cos 3 theta plus 2 sin 3 theta over cos 9 theta plus 2 sin 9 theta over cos 27 theta equals to tan 27 theta minus tan theta. Obviously we have to choose left hand side. Left hand side equals to 2 sin theta over cos 3 theta plus 2 sin 3 theta over sin, that's cos 9 theta plus 2 sin 9 theta over cos 27 theta, isn't it? We have to apply one technique, isn't it? Here 2 sin theta, let's multiply up and down by cos theta here. Here is cos 3 theta dot cos theta, correct? Here 2 sin 3 theta into cos 3 theta over cos 9 theta dot cos 3 theta. Clearly, here 2 sin 9 theta dot cos 9 theta over cos 27 theta dot cos 9 theta. So we are going to multiply the numerator and the denominator accordingly. 2 sin A dot cos A, that is sin 2A, so we write here sin 2 theta. It's correct here as it is cos 3 theta dot cos theta. Here also we can write sin 3 theta into 2, that is we can write here 2 dot 3 theta, that is cos 9 theta into cos 3 theta, plus here also sin 2 dot 9 theta, that is cos 27 theta dot cos 9 theta. So after that, let's multiply them, isn't it? So we have here sin 2 theta over cos 3 theta into cos theta, plus sin 6 theta over cos 9 theta dot cos 3 theta, plus sin 18 theta over cos 27 theta dot cos 9 theta. We have to apply one technique here, isn't it? Sin 2 theta. So we write here sin 3 theta minus theta. Can you write? 3 theta minus theta equals to 2 theta. And here cos 3 theta dot cos theta. Here also same. Here is sin 6 theta can be written as 9 theta minus 3 theta. And down of that we can write here cos 9 theta dot cos 3 theta. Here also same, sin 27 theta minus 9 theta. So can write? So can write or not? 27 minus 9 equals to 18, and that is cos 27 theta dot cos 9 theta. Isn't it? Now, so we are going to apply formula, isn't it? It's compound angle formula, sin A minus B. So we write here sin A dot cos B minus cos A dot sin B. At the denominator, cos 3 theta into cos theta. Right? Here also same, sin A minus B, sin 9 theta dot cos 3 theta minus cos 9 theta dot sin 3 theta. At the denominator, cos 9 theta dot cos 3 theta, and there is a plus. Again you write here sin 27 theta dot cos 9 theta minus cos 27 theta dot sin 9 theta over cos 27 theta dot cos 9 theta. Isn't it? So now we are going to separate the base, isn't it? So we write here sin 3 theta dot cos theta over cos 3 theta into cos theta minus cos 3 theta dot sin theta over cos 3 theta dot cos theta. Here also same, sin 9 theta dot cos 3 theta over cos 9 theta dot cos 3 theta minus cos 9 theta dot sin 3 theta over cos 9 theta dot cos 3 theta. Right? And after that we write here plus. This part also you have to do the same here also, right? We have here sin 27 theta dot cos 9 theta over cos 27 theta dot cos 9 theta minus this part cos 27 theta dot sin 9 theta over cos 27 theta dot cos 9 theta. Remember here that is sine 9 theta, okay? Don't get confused. Sine 9 theta. Okay, I'm pretty sure that's cleared, okay? You are understanding. Now we are going to cut up and down, okay? This cancelled, that also cancelled. Here cos 3 theta we can cut up and down. Here cos 9 theta we can cut up and down. Here cos 9 theta, and here cos 27 theta. You know, we can cut up and down. Remaining part we have here, see carefully, sine 3 theta by cos 3 theta, isn't it? So we can write here tan 3 theta. Can write minus sine theta, isn't it? Sine by cos plus sine 9 by cos 9, you know, we can write here. Oh, just a minute here. We write here that is tan theta, okay? Sorry, that is tan theta. That is plus, we can write here tan 9 theta. This part, here you can write here minus tan 3 theta. Yes. From here we can write plus tan 27 theta and minus, there is tan 9 theta, isn't it? Again we can cut up and down. No, not up and down, plus and minus. So we can cut plus 9 theta minus 9 theta, we can cut, isn't it? And we can cut here tan 3 theta, this also we can cut, right? And the remaining part we have here, plus is 27 theta plus, and this minus, so right here tan 27 theta minus tan theta, and see the right hand side, tan 27 theta minus tan theta we have got. So we have got here also same. So we write here at the right hand side then equals to right hand side and root. Thank you for watching this video. Keep watching. In the next videos again I'm going to show you 5 more identities. So if you like such type of educational videos, identities and others, not to forget to like and share the videos. And if you are new, then sure subscribe the channel to get the new update and hit the bell icon as well, okay? Thank you. God bless you. See you next time. Stay safe.